Now, this leads us to uniform distributions. Now, we talked earlier about uniform distributions, and now we're kind of going to go into more detail with uniform distributions. Recall that a uniform distribution is one that is evenly distributed across all possible outcomes. The shape of the density curve for a uniform distribution is a rectangle, and the probabilities are found by finding the area of rectangular regions. And recall that the area for a rectangle is base times height. So determining probabilities on a uniform distribution is very simple. Every slice of a rectangle is still going to become a rectangle. So underneath the entire uniform distribution, we have an area of 1. In any interval along that rectangle, probabilities can be found by slicing a certain section of that rectangle, which will in turn be another rectangle, and we can find that area of that shaded region, which is just simply base times height. Now, the mean of a uniform distribution is A plus B divided by 2, where A and B are the endpoints of my distribution. So all uniform distributions are defined by their endpoints. That is, the possible lowest minimum value that the random variable can take on, and the highest possible maximum value that the random variable can take on. If we average those two values, we basically come up with the mean of our uniform distribution, which will be located right at the center between the two endpoints. The standard deviation of a uniform distribution, sigma, is equal to the root of quantity b minus a squared over 12. In other words, we're going to take the range of our uniform distribution, b minus a, we're going to square that value, divide by 12, and that'll give us our variance. And then taking the square root of that quantity there will give us the standard deviation. Once again, A and B represent the endpoints of our uniform distribution. Now let's take a look at an example here. The Epsom Salt Company packs salt in containers labeled 2 pounds. Now the packaging isn't perfect, and the actual weights are uniformly distributed with a mean of 1.98 pounds and a range of 0.08 pounds. So, although the bag says 2 pounds, they ran a study and conducted some type of a test and found that the weights are basically uniformly distributed or evenly distributed, and the mean of all those bags is 1.98 pounds, and the range of those bags is 0.08 pounds. Now, they want us to construct the uniform distribution. Now, recall that all uniform distributions are going to be rectangular in shape. So, let's go ahead and draw ourselves a horizontal axis and a vertical axis, and on the horizontal axis, let's go ahead and locate the mean weight of this particular problem. The mean of all these salt bags is 1.98 pounds. Now, let's take a look at the other important piece of information that describes the distribution, and they give us the range. The range of values of all bags of salt are uniformly distributed, and the range of values is 0.08. So if I know what the center of my distribution is, I can go half the distance of the range to the right and half the distance of the range to the left to get my endpoints. So since the range is 0.08, if we move half that distance or 0.04 above the mean, we come up with a maximum value, upper endpoint of 2.02. And if we go 0.04 units below the mean, we're going to come up with a minimum value here of 1.94. So all bags of salt are going to range somewhere between 1.94 pounds and 2.02 pounds. Now, once we've established our endpoints, we can go ahead and create a rectangle. Now, the only question we have left is, what is the height of this particular rectangle? And recall that the area for any type of probability distribution for a density curve, the area has to be 1 underneath that density curve. So the area of this rectangular region must be equivalent to 1. Since the area under the density curve is 1, the height is going to be basically the reciprocal of the range, 1 over 0.08. And we're just going to leave 1.08 as a fraction here.